SAC106, problem number 1. We have a car moving along a straight road with constant acceleration. And we get some details of the motion. Let's get a sketch of that. I'll call this the start line. And this the positive x direction. And let's say at time 0, it's already well ahead of the start line. Let's put our car right there. At this is x is equal to 0. So this will be x is equal to 122 meters. And it's already moving forward at a velocity v, which is 80 kilometers, which is 1,000 meters, per hour, which is 60 minutes times 60 seconds, or 3,600 seconds. So I'll actually call that V0, the initial velocity. V0 works out to be 22.22 meters per second. I'll keep an extra significant digit. I got 4 of them here for the intermediate work. And 5 seconds later, it's up here someplace, 398 meters ahead of the start line. And it's moving. Let's assume that it's moving forward, but that could conceivably be a negative value. Oh, it can't, because there's a constant acceleration. Well, it could be slowing down. Could be a constant negative acceleration. So v we don't even know the sign of. I'll assume that it's rightward, and if it's leftward, we'll get a negative value for the rightward velocity. And they want us to get the acceleration of the car. And by the way, this was at t is equal to 0, and this is at t is equal to 5 seconds. So v is unknown, and the question is, what is that constant value of a? It applies here, applies there, and what is a? So let's check it out. We're given some information on t. We don't know v. We're given some information on x. By the way, I've used symbol x twice. I'll call this x0, the position at time 0. So we got x, t, and we want a. Solve a. So the 4 things that can be in our constant acceleration equation. We're going to look at a set of 4 constant acceleration equations. I think I'll go ahead and write those down. A is equal to, nope, I want to start the one with x. So write the one that starts with an x. X is equal to x0 plus v0t plus 1/2 at squared. V is equal to v0 plus at. V squared is equal to v0 squared plus 2a delta x, which is x minus x0. And x is x0 plus the average velocity times the time. And again, these are constant acceleration equations, only good for constant acceleration. We've got three things. We want an equation that's got three things: x, t, and a, and it's missing one thing, namely the v. That's often the easiest way to find it. Which one doesn't have a v in it? Of course, it says v0, but no v. It's the first one. Look, there's a v there in the second one, a v there in the third one, and a v there in the order I've written them down, and what's the fourth one. But there's no v in that one, so indeed, this is the constant acceleration equation that we need in order to find the acceleration given t and x. And we're also given some of those initial values, the x0 and the v0. So let's go ahead and use that one. Just copy it down to start with. X is equal to x0 plus v0t plus 1/2 at squared. And what we have to do is solve that for a. I'll start by subtracting these two from both sides, these two terms, and switching sides. So on the right, all I'm left with is 1/2 at squared. I'm switching sides, so that goes over to the left. And on the left, I've got the original x. Then I said I'm subtracting x0 and v0t from both sides, so that's minus x0 minus v0t. And I'll multiply both sides by 2 and divide both sides by t squared. At the same time, so I've got 2 times x minus x0 minus v0t, all divided by a. T squared, sorry. I'm solving for a. So multiply both sides by 2, divided both sides by t squared, and that's what I'm left with. So I can just go ahead and substitute the values at this point. That's 2 times the x was 398, x0, by the way, 122. So 398 meters minus 122 meters minus v0, 22.22 meters per second in SI units, and I've got to get everything in SI units for the units to work out. And the t, I remember, as being 5 seconds. I'm going to make that into a bracket. There we go. And that evaluates to 13.19 meters per second squared. Which rounds to 3 sig figs is 13.2 meters per second squared. The fact that it came out positive tells us that it's in the forward direction. So the magnitude is just the exact same value, and had it come out negative, I would have stripped the minus sign and written the word backward. The algebraic sign has given us the direction. Okay, there's a part B to this one. Let's just underline it there. Let's take a look at the part B. Find the velocity of the car. Looks like there's a letter O missing right there. Find the velocity of the car at time t is equal to 5 seconds. And this time I could actually use any of the equations that have velocity in it because I know everything else. The easy one from the set of constant acceleration equations would be v is equal to v0 plus at. So I use that. Since I'm solving for v and I've already got v on the left side, it'll just be a plug-in. Now that I've got a. Would not be a bad idea to use this one in that this involves only given quantities, but you got to use your own discretion here. That would make for more algebra. This one looks like the wiser way to go. So I'll substitute in the known value of V0, 22.22 meters per second, plus the value of A. Again, I'm keeping one extra sig fig for the intermediate results. So there's the 13.19 meters per second squared. And then times the 5 seconds, since they want the velocity at the 5-second mark. And I get V is equal to 88.2 rounded to 3 sig figs meters per second. Came out to be a positive value, which means forward, in the positive x direction. And that does it for SAC 106, problem number 1.